Started there from nowhere. Okay, JavaScript objects. We'll talk about what JavaScript objects are, and we've used a few of them already, but we're just going to talk about them in a little more detail, a little formally. And we'll talk about object programming terminology and techniques, as well as some ideas of encapsulation and data hiding. Talk about that. Some of the built-in JavaScript objects that are very useful. The math object, which I think we may have used already a little bit. String and date, which I think we touched upon as well. Boolean and number. So the ones you'll use probably most frequently would be math, string and date. Boolean and number a little less often. And we'll also talk about HTML5 web storage to create a web application that uses user data locally. Not sure how well this is going to work because it's not widely supported. I think it'll work on Safari, but that may be about it. Or Google. It might work on Google as well. Again, the math object and the string object we'll talk about, the data object, Boolean and number objects. We'll look at some examples, something called the Twitter searches, which is new. Talk about JSON, which is JavaScript object notation to represent objects. And this is really going to come into play a little later on when we get to some Web 2.0 stuff. This chapter presents a more formal treatment of objects. We've used objects in the past with some of our examples, but now we're going to formally talk about them. We use HTML5's new web storage capability to create a web application that stores a user's favorite Twitter searches on the computer for easy access at a later time. We also provide a brief introduction about JSON or JavaScript object notation, what it is. And that is, JSON is essentially an alternative to XML. And it's actually a very good alternative to XML. It's about 100 times faster than XML, so it's quite good. I generally use JSON over XML because it's just so much faster. Talking about the math object, which is another object for dealing with math, and I think we've used this already for the random number generator and possibly a few other things. We've already seen how we have to use the dot operator when we're talking about objects, between the window.alert, for example. So window is an object, as is document, and we'll talk about how they're used. We'll talk about the difference between invoking a standalone function and invoking a method of an object. Is that an object name and dot are required. So we've seen that before. We'll go over that again. Again, we'll go over the math object. I know we've used a few of these methods in math object, but I don't think we've formally gone through the math object. It's got a lot of nice things in it that allow you to do more advanced stuff than algebra. I like to compare this in Windows to the calculator function, the calculator program, where the normal view allows you to use it just like a regular calculator to do addition, subtraction, multiplication, division, and so forth. But then you have a scientific portion of a calculator. When you click on it, that gives you all kinds of things like cosine and exponential and tangent and all these other great things. And that's kind of like what the math object is. It gives you access to all that more advanced stuff than basic algebra. So you don't have to remember the formulas. It's all nicely bundled in the math object. And again, we've got more as well. Min, pow, round, sin, sine, trigonomic sine of x, square root, tangent, and so forth. Math also has some constants that are useful. E is the natural logarithm of e, essentially 2.18. There's ln2, natural logarithm of 2, and some different ones like that. Also pi is in there, which is 3.14, so forth down the line. And then we've got the square root of various values that are useful. There's some useful constants there as well. We'll also get into the string object, and we've kind of used this one as well, but just through the variable declaration, and there's an implied conversion to string, and we've seen some of the basic stuff to use there. We'll get into a little more formality about the actual string object and all of its capabilities. Also, how we kind of already know how some of the the plus sign operates on strings. We know that it acts as a concatenation, but then there's other characters that are special as well. We'll talk about that. JavaScript supports something called Unicode. I think on the first day, probably talked about this. ASCII code, series of zeros and ones, usually 8 bits is 1 byte, is 1 character, that's ASCII. But that only covers up to 255 characters. Binary, you guys remember talking about binary? On day 1, I think. Unicode is essentially 8 bits makes up 1 byte, and 2 bytes equals 1 character. So now under Unicode, it's twice as big. Well, the number of bytes it requires for a single character is twice as much. 16 instead of 8 bits, I should say, bits, not bytes. But the advantage is it gives you go from a top unique number of characters of 255 to 65,000, which is enough to store all the characters of every language on the planet. So that's why they use Unicode, and that's why the world moved to Unicode, so that it could support that. But it does take twice as much memory. So bits and bytes. Hopefully, it sounds familiar. I'm pretty sure I covered that on our. Pretty sure on the first lecture. Actually. See, binary. Remember this? We did this on day 1. How it works. Binary and Unicode. So we covered that. All right. So we'll talk about that, and we'll talk about string literals versus constants. What's the difference? And also using single and double quotes. What's the difference there? There really is none. Combining strings is called concatenation, and I think we've already done string concatenation, because we've done a few things where we've had to do string concatenation already. But the string object also has a number of functions that are very useful, and we may have looked at a few of these, but it's very useful. It's got char add, and we'll see some examples of this in a moment, where you can pull a single character out of a particular location of the string. Char code at returns a Unicode value. Concat is an alternate way of doing concatenation, or you just use the plus sign. From char code converts a list of Unicode values into a string containing those characters. Index of will tell you where it finds that character or characters within a string, the first location of it. Last index of looks for the last one of that. And there's an alternate second value which says you want to start the search from a certain location. Replace will replace one string that it finds with another. This is like a find replace sort of thing. And slice returns a string containing a portion of the string, or a substring almost of it. Split is another one that's also very useful, split, particularly in some Web 2.0 stuff. It converts a delimited string into an array, and we'll talk about an array. I think we've already talked about arrays, but we'll talk about it a little more. A substring has a start. We'll pull a substring out, and there's a couple of different substring methods. There's substir and substring. And I think this comes from the fact that there's basically 2 ways of doing substrings, and JavaScript just decided to include both in there. And also you can convert the entire thing to lowercase or convert the entire thing to uppercase. Okay, so we're going to talk about this a little more, and we will get into some examples real soon. String method char at returns the character at a specific location. Indices for the character in a string start at 0. It's 0 base, just like arrays, because a string is essentially an array of characters. The first character can go up to, but not include the string's length, because just like arrays, the actual last index would be length minus 1, because it starts at 0. Char code out returns the Unicode value of the character at a specified position. If the index is outside the bounds of the string, the method returns a NaN, which means not a number. It just means you went beyond the length of the string. String method from char code returns a string created from a series of Unicode values. So you can give it as many Unicode values as you want, and it will create a string from that. And then lowercase and uppercase just converts the entire string to either all lower or all uppercase characters. Okay, our first example here we're going to look at, which is right here. And we'll look at the source code for this one. Fairly straightforward. So we create a couple of strings, and we don't really need to create the string object. It's when you create a variable and you assign a string to it, JavaScript makes that assumption for you, unlike a lot of other languages. JavaScript assumes that for you. And so we create those two, and we can see that we're going to look at, one of the first one is the character at index 0 for S, and these are all string concatenations with the plus sign, is s.char at 0. So it essentially pulls the first character out. If we change this to 1, we'd get E. If we change it to 2, we'd get B. So it's counting it along. To get the char code at it, it says 90, right? Because Z, the Unicode value for Z is 90. We know that A is 65, so just count up the alphabet and you get to 90. And then we can create a string from those Unicode values of 87, 79, 82, 68, and we know that the first one, the W, would be, I guess, at 87. We know that A is 65, so it's inclusive, so 68 would be D, which is exactly what it is right there, right? That's a D right there. And then it shows converting it all to uppercase and all to lowercase as well. So the mixed case ABC here, all in lowercase and all in uppercase. So it's fairly straightforward. String parsing is a very useful thing to know. It's involved in an awful lot of file transfers and manipulating of data. It's also involved in what we call the Web 2.0 technologies, and you'll see it in a lot of applications. The ability to manipulate a string of data, convert it somehow, and do all kinds of things with it. Again, you can see the data creating the strings, now putting the character at 0, which is Z, and the char code is Z is 90. String method index of determines the location of the first occurrence of its argument in the string. So, and if it doesn't find it, it returns -1. And that's because the very first character in a string starts with 0. So 0, it's like an array, 0. So -1 means that it didn't find it. It's going to find the first occurrence of it, and we'll see that example in a moment too. Last index of just goes from the reverse. Right, so it looks at the end of the string, so it's looking for the last occurrence of a particular character or set of strings, or set of characters, a substring. And there's some alternate, couple of variations on this as well. And that would be our next example. Oh, okay, so we'll look at what this does. But here we're going to say, I'm just going to look for NOP, right? And what we get, it says, okay, the first occurrence and the last occurrence, but well, so that wasn't a great example. Let's try DEF. Okay, so now we see the first occurrence was at 3, and if you look at it, it's right there. Remember that A would be 0, B 1, and C 2, so it starts there. And the last occurrence would be, we look back here, we've got DEF as well, and that, I assume is character 29. The first occurrence from index 12, it would be afterwards, right? Because it would be, so the first occurrence, because we start at index 12, which is somewhere over here, and then it searches forward, then it finds DEF as the first one because we gave it a starting value. And let's look at the code. That'll probably make it a little easier to see. Okay, so button searched, letters.index of input value, which is what I typed there, DEF. And then the second one was the last index of. Now this one starts a little different because it gives a second argument, which is optional on index of and last index of. That just means indicates a starting point. Otherwise, the index of or last index of, well, the index of assumes 0 as the starting point, unless you give it a number. And last index of assumes the very last position. Okay, so that's how we got at those different couple of numbers. Any questions on this one?